Welcome to section 11.9, solving radical equations. This is video number 1, and in this video we are going to talk about what radical equations are, how to solve simple radical equations, and how to solve them by adding, subtracting, multiplying, and dividing. Here we go. What is, first of all, the difference between an equation and expression? And the whole concept between a radical equation and expression here, right here, this square root of 7 divided by 2, that is an expression. If we look over here at square root of 7 over 2 equals x, that is an equation. It's an equation because it has an equal sign. We can solve for something in that. If you wanted to, you could technically solve for something here. However, you're not asked to solve for anything because there is no equal sign. So you don't need to go there, which is awesome. That's kind of cool. But now you do need to go there. For the next section, you need to actually find the answer. So let's get started. The power property of equality. You can square both sides of an equation, and the resulting equation will still be true. So let's work ourselves through this equation right here. We know 3 is equal to 1 plus 2, right? That's awesome. Now, if we were to square 3 and square 1 plus 2, we could get the same answer. So 3 squared becomes 9, and 1 plus 2 squared is also equal to 9 because 1 plus 2 is equal to 3 and 3 squared is equal to 9. So we get our final answer. Now let's use this concept to solve some basic radical equations. And really big, super important. I'm not going to do it on every single problem, but I want you to always make sure that you are checking your work with these, because when you square both sides of an equation, sometimes you end up with an answer that doesn't actually work. Because we know that when you square something or you take the square root of something, you can get two answers, both a positive and a negative answer. And I know I've said in the past, only focus on the positive as of right now. However, if we check our work, we can find what the true answer is and be able to be okay with our true answer. So we have square root of x is equal to 8. So if we are going to take the square root of both sides, we get x is equal to 8 squared, which is 64. Awesome. So if we were then to check our work, if we had the square root of x is equal to 8, if we were to take the square root of 64 and say that was equal to 8, we'd be right every single time because 64 equals 8, and 8 is equal to 8. So awesome. It checks out. Cool. So let's try another problem. We have 6 is equal to the square root of 4x. So first things first, let's square both sides. And the reason why we're doing that is we are trying to find what just x is, not the square root of 4x, not the 4x. We're just trying to find x. So if we take the square root, or if we square 6, we get 36. And if we take the square root of 4x and square that, we just get 4x. We're going to then, after that, divide by 4 on both sides. So 36 divided by 4 is equal to 9, and that is equal to x. 9 is equal to x. So let's now check our work. We have 6 is equal to square root of 4 times 9. Square root of 4 times 9 is equal to 36. So is 6 is equal to the square root of 36? Yep, because 36, the square root of that is equal to 6. Awesome, so that works. Let's try another one. 9 is equal to the square root of 27x. We're going to square the square root of 27x, square the 9, so we get 81 is equal to 27x. We can then divide by 27. Divide by 27. 81 divided by 27 is equal to 3. So x is equal to 3. Let's try our hand at this and see if we get the same answer. So 9 is equal to the square root of 27 times 8. Oh, whoops, not times 8, times 3. I didn't mean to do that. I was looking at something out of the corner of my eye. Times 3. So 9 is equal to the square root of 81, and the square root of 81 is equal to not 8, but 9. I'm having fun with 8s as of right now, and that is a true statement. 9 is always equal to 9. So now let's solve some radical equations by adding or subtracting. And again, like I said before, always check your work. Square root of x plus 3 is equal to 10. So let's now subtract 3. If we subtract 3 from both sides, then we can actually solve for just what x is. As of right now, we're going to be solving for the square root of x. So the square root of x is equal to 7. And now we can square both sides. So x is equal to 49. Let's check our work. Let's put the square root of 49 plus 3 is equal to 10. Square root of 49, if we were to do that, we got 7. So 7 plus 3 is equal to 10, and we know that checks out. That's okay. Let's do the next problem. Square root of x minus 5 is equal to 4. So square both sides. We get x minus 5 is equal to 4 squared, which is 16. And now we're going to add 5. So we have x is equal to 21. Let's check our work. Let's say square root of 21 minus 5 is equal to 4. Oops, that minus 5 should be in purple. 21 minus 5 is equal to 16, and that is equal to 4. Square root of 16 is equal to 4, which is equal to 4. Awesome, we got it. One last problem for adding and subtracting. Let's subtract 4 from both sides on this one. Oops, and I subtract 5, of course, and that's not keeping things balanced. First of all, I should say the problem. Square root of 2x minus 1 plus 4 is equal to 7. So that 2x minus 1 is the only part that is under the square root. The plus 4 is on the outside. So now we have the square root of 2x minus 1 is equal to 7 minus 4, which is 3. We're now going to square root both sides. So we get 2x minus 1 is equal to 9. Now we know how to do this math right here. We've done this math before. We're going to add 1 to both sides. So we get 2x is equal to 10. And then we're going to divide by 2. And we get x is equal to 5. Let's check our work by putting that in our original equation. We have the square root of 2 times 5 minus 1. I'm going to shorten this thing up. Plus 4 is equal to 7. So 2 times 5 is 10 minus 1 is equal to 9. So the square root of 9 plus 4 is equal to 7. Square root of 9 is equal to 3. So 3 plus 4 is equal to 7. And so 7 is equal to 7. Awesome. We got it. Let's try one last method of solving equations. Solving radical equations by multiplying or dividing. This is our last method of solving equations. In multiplying and dividing, we can do it one of two ways. This is primarily solving with multiplying in this case. So method number 1 tells us we can essentially divide by 3 first. So we have the square root of x is equal to 21 divided by 3, which is 7. After that, we can square both sides, and we get x is equal to the square root, or 7 squared, which is 49. Now let's see if method number 2 gets us the same sort of thing. We're going to, instead of dividing first, we are going to square things first. Square them. So 3 squared is equal to 9, and the square root of x is equal to x. Or square root of x squared is equal to x, and that is equal to the square root of 21, which is 441. After that, we can divide by 9, and we get simply x is equal to 49. And if we notice, we got the same answer. Now that doesn't necessarily mean we're right. We actually need to check our work. So let's check our work right here in the middle. We have 3 square root 49 is equal to 21. Square root of 49 is equal to 7. So we have 3 times 7, which is equal to 21. 3 times 7 is 21, so 21 is equal to 21. Checks out, so 49, x equals 49 is our answer. Let's try one more problem. We're going to try both methods, so we can either square something first or we could multiply or divide something first. Our very first problem, let's multiply by 3 on the top and on both sides. And the reason why we're multiplying by 3 is we're getting divided by 3. So the opposite or the inverse operation of that is multiplying by 3. So we get the square root of x is equal to 15. And then after that, we're going to square both sides. So we get x is equal to 225. Let's try our hand at the other method. So the other method means we'd square things first. Square things first. So square root of x squared, square root of x squared, or square root of x squared is equal to simply x, which I don't actually have there, x, and 3 squared is 9, and that is equal to square root of 5, or 5 squared, which is 25. After that, we can multiply by 9, so x is equal to 25 times 9, which is 225. Same answer. Last but not least, we should check our work, so we get essentially 225, 225, square root of 225 divided by 3 is equal to 5. So the square root of 225 is 15, so we have 15 divided by 3, which is equal to 5, and 15 divided by 3, if we did that math right there, we get 5 is equal to 5. Checks out, it's totally set and ready to go, so we've solved that equation. So we've now tried to solve equations by adding, subtracting, multiplying, and dividing. We've also solved basic radical expressions using square roots. So the only thing that we were really adding to our arsenal with solving equations or radical equations with adding and subtracting, multiplying, and dividing is the concept of being able to square both sides of the equation. Other than that, this is exactly the same as solving equations that we've done when we were just solving for a single variable. So pay close attention to that. We're not really adding too much more. Play around with the homework and don't forget to watch video number 2. It'll help you with the last little bit of this, which is actually understanding extraneous solutions. So enjoy, and I will see you later. Bye.